remember, polynomials just means there is a power, there's an integer, it's a whole number up here. I shouldn't say an integer, it's a whole number, positive. This is x to the first, this is x to the 0 as well. But this is what the polynomial is. You won't see any fractions or anything like that on these. You cannot have an x to the negative 2. You can't have x on the bottom. But you can have all of these here. If you notice there's x's and y's combined here, we're not dealing with that this year because of everything that's going on. I'm going to keep it all the same. Everything's just going to be x. There's no x's and y's. It just makes things more complicated. Polynomials are a smooth curve. Okay, there's no holes, jumps, or gaps. There's these hills and valleys. The degree of polynomials, it's the highest power. So whatever the highest exponent is there, so the third power, that's the highest power, it's 3. Okay. This one, the highest power would be 6, so it'd be a degree of 6. Standard form, don't worry about it, but just it's in order by the power, but I'm not going to try to trick you on that. Even polynomials, the ends go to the same place, so it forms like a U-shaped thing like this, or sometimes a W or an M. Either way, the ends go to the same place, either up or down. For odds, they go in opposite directions, so as one goes up, the other one's going down, or vice versa. Okay. Relative extrema, that's those terns. So however many terns there are, the maximum amount of terns will be whatever the degree is minus 1. So if the degree is 4, there could be 3 terns, there could be 2 terns, there can be 1 turn. There has to be at least 1. Okay. But there can't be any more than 4. All right, fundamental theorem of algebra, for whatever that power is, that's how many answers there are, how many solutions. So if it's 4th root, there's 4 answers. If it's 5th root, there's 5 answers. Kind of just talked about this. Yeah, zeros, solutions, roots, answers, that's kind of all the same thing here. It's just where they intersect the x-axis. We're not worried about complex pairs for this one. The graphs, the things we talked about is if it's a positive leading coefficient, it goes up when you go to the right. And if it's negative, it goes down. You should know that. If you notice, this one still goes up. If it's positive, this one goes down. If it's negative, up right here, down over here. The lowest possible degree that you can have is you count the turns and add 1. So this one right here, there's 2 turns. So this is x to the 3rd. Okay, the lowest possible. This one right here, there's 1 turn. You add 1, it's 2. So this is x squared. As you can see, it's quadratic. This one, there's no turns. So it's a power of 1. Power of 1 means it's linear. Okay, X-intercepts, it's where it intersects the x-axis, not intersect the x-axis. So there's still 2 solutions. They're just imaginary. We went over that in the last unit. Y-intercept, there's always a y-intercept, and then you can just look at the graph to figure out where it is, or you can just plug in 0 for x. So if I plug in 0 for x, 0 plus 0 minus 2, that means 0 plus 0 is 0, minus 2 is negative 2. Negative 2 right there. Okay. 0 plus 0 plus 1 is 1. There's the 1 right there. That's the y-intercept. The x-intercept, you have to set the y equal to 0. Solve. Okay, so you would have to set like this up here equal to 0 and solve. All right, multiplicity. If it's a multiplicity just means it's the same factor. So if you notice x minus 3 and x minus 3, that means 3 is a multiplicity of 2 because there's 2 of them. Even multiplicity bounces. Odd multiplicity goes through. Okay, you have to know that. Hopefully, it's written in your notes, so that way you can use your notes on the test. If there's no multiplicity, it just goes straight through it. So it's linear. This one, it goes through it, but if you notice, it curves a little bit. Okay. Let's see here. Multiplicity, I already talked about that. Sometimes with multiplicities, you can have multiple answers. For example, this one has 3 answers that are 0, and then 1 answer that's negative 1. So that's 4 answers. There's 3 zeros, and then 1 negative 1. So that's 4 answers, and it matches what we have right here with the x to the 4. Again, just to review, if it's even, it bounces like right here. If it's odd, it goes through. Okay. Polynomial division, we went over transforming this by factoring into actually doing it the long way. Are there any questions on how to do that? Any questions from the homework or anything? Factor theorem, or it's also called remainder theorem. Okay, so I'm going to write that down first because that's the name of the section. Okay, so factor / remainder theorem. And it's directly related to what we just did. And I swear it's not a hard concept. It sounds like it is because it's like remainder theorem? What is this theorem nonsense? This is crazy. I promise it'll make sense. Okay. So, and what we're going to use is this example right here. So let me screenshot this. Blow it up a little bit. Okay, just as a review, we're going to actually go through this problem really quick. But let me get rid of this orange here. There we go. Now it looks a little cleaner. All right. So if you remember, the first thing that you want to do is look at the leading term and this leading term here and think, what do I have to multiply this by to get x squared? The answer would be x. So x times x is that x squared. So now we're going to have x squared over here minus x in parentheses, and then we're subtracting. Okay, so you're taking this x and multiplying it by these two things here to get what I have there, the x squared minus x. Okay. Now from here, this negative becomes this negative, and this becomes positive. This cancels. That will always happen if you're doing it right. And then you do 3x plus x is 4x minus 4. Okay, and then up here you think, what do you multiply this x by to get 4x? Well, just 4. All right, so I'm going to put a 4x minus 4 in there because you multiply this 4 by each of these things over here. You get 4x minus 4. And then you subtract them again. And this one's kind of nice because you end up with no remainder, and you're done with the answer. You're done with the problem. So the answer for this one is x plus 4. Now you might be thinking, okay, we did that yesterday. Why is he going over that today? Because it's actually related to remainder theorem. And the fact that the remainder is 0 is a big deal. Now watch this. What we're going to do is we're going to take this part right here that's inside the divided by right here, this x squared plus 3x minus 4. So I'm going to write that over here. I'm going to say f of x is equal to x squared plus 3x minus 4. Okay, this I actually want you to write down. So if you didn't write down the stuff on the left, that's fine. But I definitely want you to write down the blue. Okay, now what I want someone to do is I want someone to find what is f of negative 4. Okay, so if I plug negative 4 into this equation right here, what would I get? And then just yell it out once you get it, because we're all friends here. 0, exactly. Okay, so if you actually worked all this out, you should get 0. So it's going to be 16 minus 12 minus 4. Oops. So cancel, cancel, that's going to be 4. And then 4, this cancels too. 4 minus 4 is equal to 0. Okay. Now, this basically is remainder theorem. And the way it works is if you took your answer, which is this thing right here, and set it equal to 0, and solved, you would get x equals negative 4. If that is a factor, which means there's no remainder, if you plugged in this negative 4 into the top part of the equation, which is that's what I did. I took this negative 4. That's why I plugged it into that top equation, that x squared plus 3x minus 4, that expression, I should say. You end up with 0. Okay? When that happens, when you get 0, this is basically remainder theorem. If you get 0 as a remainder, then whatever your answer is a factor. Okay? And that is a factor of this x squared plus 3x minus 2. Because I can rewrite it if I wanted. This x squared, here, I'll write it over here. X squared plus 3x minus 4 is going to be x plus 4 times x minus 1. Okay? And if you notice, because I plugged the negative 4 in there, it does show that it is one of the factors. Okay? So if there is a 0 there, that means that it's definitely a factor. That's why it's called factor/remainder theorem, because it shows that if the remainder is 0, then it is a factor. If the remainder is not 0, then it's not a factor. Okay? If the remainder is not 0, then it is not a factor. So what I want you to do now is write that in English. Like, how could you remember this? I mean, I'll write it as well, just so it's easier. But the way this theorem works, it just is... If the remainder is 0, then I'm going to say that it's a factor, but I don't want to say it because then it's like, then your answer, I'll just say your answer, I guess, is a factor. Okay. So to test this out, what I want you to do next is find out what is f of 1. Okay. Well, you don't have to even really do any math for this based on the fact that we already know it's a factor. So if factor theorem is true, which it is, what should my answer be? 0. So essentially what I did here is go backwards. I said if my answer is a factor, which right here, x minus 1, so I plugged in a 1 because if you break it down, x minus 1 equals 0, x is equal to 1. So it's like the opposite of what's there. It's a negative 1, so I plugged in a 1. It is equal to 0. Okay, but let's say you didn't believe me. You can just want to test it out. You can do 1 squared plus 3 times 1 minus 4. Okay, well that's going to be 1 plus 3 is 4 minus 4 is 0. So it actually is 0. Okay. Now just for fun, let's pick a number that's not in here. Let's pick let's 0. 0 is not going to be one of the solutions to this. It's not going to be, x is not a factor for this. So if you plugged in 0 to this f equation, what do you get? Anybody, just yell it out. What's f of 0?
0.
Well, it's going to be 0 squared plus 3 times 0. It can't be 0 because if it was 0, then it'd be a factor. Negative 4. So it'd be 0 plus 0 minus 4. So you got to remember that minus 4 part of it. Now, since it's equal to negative 4, that means that it's not a factor. So you'd say, not a factor. So you're going to be given certain questions that's going to say, is the following a factor? Now, if you wanted to, you could just do long division and figure out, you can do long division and figure out if it's a factor or not. But an easier way of doing it is just plugging it into the top part of the equation, top part of the expression, whatever you're dividing, and testing it out that way. Okay, it's negative 4, so x is technically not a factor of this. If you plug in any other number, you're not going to get 0. Okay, because it's no other numbers besides negative 4 and 1 are factors of this. Okay. So the part of factor theorem would be if the remainder is not 0, then your answer is not a factor. That's essentially how it works.
So what is non-zero? Your answer would be not a factor.
Right, exactly. And I'm going to actually show you example problems that are going to look like this. I'm going to do it right now. So we'll do a couple of these, and then it's pretty much all we're going to do. There's no homework on this. We're gonna literally start Monday by just going over this again. Okay. I think repetition is good, especially with a class like this. So, and by the way, I do apologize if you're like, why did he go over all the stuff we already knew? Well, some people don't know it, and I do just like rehashing stuff, so I do apologize for that. Let's do a problem here and try to figure out what's going on. So it would say something like this. And I'm going to make it look like the last problem we just did. So it says like, is x squared minus 2x plus 1, okay? So here, I'm going to write example on this. So here is some function. I'll just say y equals in front of it. Okay, and the question would be, is x plus 1, I don't know why I'm putting it in parentheses, you don't need to, but is this a factor of y? Okay, so what value do I need to plug into y to see if it's a factor? It's either going to be 1 or negative 1. So which one is it? Negative 1. You always do the opposite of what's here. Very good, thank you. You do the opposite. That's a plus 1, so throw a negative 1 in there. So let's do that. You can even use your calculator if you want. So y of negative 1 is equal to negative 1 squared minus 2 times negative 1 plus 1. Okay, work all this out. Again, you can use your calculator if you want. 1 plus 2 plus 1 is 3. So your answer would be what for if this is a factor? No, thank you. The answer would be no. Okay, and the reason why is because that's not 0. If it was equal to 0, then it's a factor. So on the same question, I'm going to ask you this. What about, is x minus 1 a factor? Okay. What value am I plugging in this time to y?
1.
Thank you. So now it's going to be 1 squared minus 2 times 1 plus 1. And that's going to get you 1 minus 2 plus 1, which is equal to, I'm going to do this first part right here. That's equal to negative 1 plus 1. Well, that's equal to 0. So your answer for this one would be yes. Thank you. There we go. Now, just for fun, I don't want anyone writing this down because I just want your brains for right now. But just for fun, I'm going to actually work all of this out, okay, with long division. But I don't want anyone doing it because, unless you really want to, but I just kind of want you to understand this concept. So watch this. If I do x squared minus 2x plus 1, and we're dividing this by x plus 1, okay. And again, the reason I don't want you to write it down is because I wanted to kind of go faster a little bit. So this is going to be x, because x times x is the x squared. Then you have to multiply it by the x here and the plus 1. So that's plus x. Parentheses, subtract. That's x squared. Okay, just do right here. This. So then you have negative 2x minus x is negative 3x. The plus 1 drops down. And then you have to think, what do you multiply this x by to get negative 3? You multiply it by negative 3. I'm sorry, negative 3x. You multiply it by negative 3. So now you're going to get negative 3x minus 3, parentheses, subtract. Let's distribute this negative here. Cancel, cancel, and you're left with 4. Okay? That's your remainder. So you can write it as 4 plus x plus 1. But check this out. You'll notice that that remainder that we got here is also equal to this right here. Okay? That will always happen. That's also part of remainder theorem. Whatever if you plug in a negative 1, which remember it's the opposite of what's here, that plus 1, I put a negative 1 in, the remainders will match. So sometimes there'll be a problem where it says, what's the remainder of this divided by this? All you have to do is plug it in. Don't do all the long division, just plug it in. Okay? I can tell you right now in your test, in your quiz, it's just going to be one long division problem. Okay, there's only going to be one. Because these take a long time, and why beat a dead horse? Like, let's just keep it simple. So you can just tell me what the remainder is from there, or you can go the full, do the full problem out, but seems like a longer way of doing it. That bottom one, if you do the exact same problem, so I'm going to just do the problem again, only with the x minus 1 in the front. So x minus 1, and then x squared minus 2x plus 1. Divide this out here. So we're putting an x up here, and you get x squared minus x. You should notice the remainder is going to be 0 on this, if you want to kind of think ahead. Cancel, cancel. This negative x plus 1. Okay. You have to multiply this by negative 1 to get the negative x plus 1, and there you go. That all cancels out, so you have a remainder of 0. And if you notice, that does match with what we had before when you plugged in 1 directly right here. Okay. So again, this is just an extension of what you've already done. It's just you're plugging in a certain value. You still got to know long division because, again, there's going to be one question that you have to do that with. And then there's going to be stuff about the remainder or whether something's a factor or not. So you have to use the factor/remainder theorem for that.